baby shark, baby shark, baby shark. Mommy shark, mommy shark, mommy shark, mommy shark. Daddy shark, daddy shark, daddy shark, daddy shark.
Okay, I'm done. I just realized I did that with my sophomores and not you, and that is not fair. Anyways, welcome to 5.1 Homework Help. Let's just roll right into it. So, the first two, it says to substitute the given points into both equations to determine which ordered pair satisfies the system of linear equations. Graph both equations and label the point of intersection to verify the solution. So this is what we did at the beginning of class. This is why we did what we did at the beginning of class. So, here's number one. You are trying this by yourself first. And then if you need help or get stuck, come watch me, right? So go ahead. If you have not tried it by yourself, pause me and try it. Okay, did you pause me and try it? Here we go. So what you're doing, see, I need green, black, and blue. You obviously don't have to color coordinate. Can you take me seriously with my stickers? Okay. So here we go. You're going to substitute each point in until you find a point that works for both equations. It has to work for both. So my first one is 0, -2. So x is 0, y is -2. So y is -2. So I'm going to substitute -2 in for y. Y is -2. -2. X is 0. So you're substituting 0 in for x. Can we see that? Is green okay? Yeah, not bad. And then -2. Rewrite the rest of the equation. Okay. So all I did was substitute -2 in for y and 0 in for x. Now you just need to simplify it. Now, so -2 equals 3 times 0. What's 3 times 0? It's 0. And then rewrite -2. So I get -2 equals 0 minus 2 is -2. So this equation works for the first one, okay? So it works for the first equation. Does it work for this one? It has to work for both. It has to work for both. So once again, y is -2. So I'm going to substitute -2. Here, I'll draw a line. I'm going to substitute -2 in for y. -2. And then x is 0. X is 0. So I'm substituting 0 in for x. Ta-da! And that's all you have to do for this one. That's it. Is -2 equal to 0? No. -2 is not the same as 0. If I owe someone, let's say Chris owes me $2. He's like, how about I just give you $0, Miss Bailey? So no. So the first one does not work. It must work for both of them. So it works for the first equation, but not the second. So no. Ooh, no. Okay, let's move on to the next point. Ugh. So your next point is 2, 2. X is 2, y is 2. So let's substitute it in. Once again, try it by yourself. So pause me and try it. Pause me and try it. Okay. Substitute 2 in for y. And 2 in for x. Rewrite the rest of it. Okay. So you get 2 equals 3 times 2 is 6. minus 2. So you get 6 minus 2 is 4. So is 2 equal to 4? No, we can always, so like, if I have 2 pigs and Chastity has 4 pigs, do we have the same amount of pigs? No. No. So this does not work. Just for practice, you can already stop at this point because it does not work here. It has to work in both. So if you try it and it does not work here, you can stop. But just for practice, let's substitute it into the other equation. Just for practice. So y is 2. And x is also 2. So is 2 equal to 2? Yes. Okay. So this point does not work here, but it works here. It has to work in both. So no. So that probably means it's the third point. So let's try the third point. Okay, try it first. So pause me and try it. Okay, here we go. So y is 1. No, sorry. Well, yeah, y is 1. Y is 1. Oh. Okay. X is also 1. So substitute in for x. And then you have minus 2. And simplify it. 3 times 1 is 3. And then rewrite the minus 2. So you get 1 equals 3 minus 2, which is 1. So 1 is, in fact, equal to 1, so that works. But doesn't work in our other equation. It has to work in both. So y is 1. And x is also 1. So is this true? Yes, it is. So that would be your answer. Your answer is 1, 1, which is C? Yeah, which is C. So this point is the solution to this system of equations. It works in both equations. Okay. Let me pause you for a second because I think we have to graph it. All right. So the second part, it says graph both equations and label the point of intersection to verify the solution. So what that means is our solution was C, 1, 1. So is that where they intersect? So we're checking to make sure we're right. They should intersect at 1, 1. So I'll graph, I don't know. Let's graph y equals x first because it's fairly easy. So if you graph line y equals x, if x is 0, y is 0. If x is 1, y is 1. They're equal to each other. So whatever x is, that's what y is. When x is 2, y is 2. When x is 3, y is 3. When x is 4, y is 4. When x is 5, y is 5. Same thing going this way. X is negative 1, so is y. Negative 2. This is where we start to get not straight. Negative 2. Negative 3. Negative 3. Okay, and so on. Let me draw my line. Well, it's better. Okay, make sure it goes through there. Okay, I'll make it match up after I draw it. This is why graph paper is helpful. But we should get the idea. I'll just move my points so they're on the line. Okay, so that's your line y equals x. Then you have to graph the other line, 3x minus 2. You can graph it by substituting points in for x and solving. So you can always make a table. X, y, So if x is 0, substitute 0 in for x. What do you get when you substitute 0 in for x? 3 times 0, so you get 0 minus 2, negative 2. Okay, substitute 1 in for x. If x is 1, what is y? That would be 3 times 1 minus 2. You would substitute whatever you're putting in for x, you substitute in for x. So that would be 3 minus 2, which equals 1. If x is 2, what is y? So you would go 3 times 2 minus 2, which is 6 minus 2, which is 4. And then just to be safe, we'll do one on the negative side. So let's just do negative 1. If x is negative 1, what is y? You're going to substitute negative 1 in for x. So you get negative 1 times 3 is negative 3 minus 2 is negative 5. Yeah. All right. So let's go ahead. So you can graph it based on your table. You can also just start with my y-intercept. My y-intercept is negative 2. This is in the form. Okay. Well, B is your y-intercept, so your y-intercept is negative 2. Let's graph it in red, I guess. So my y-intercept is negative 2. And then my slope is 3, which means my slope is 3 over 1. So I'm going to go, change in y is 3, change in x is 1. So up 3, 1, 2, 3, over 1. Oh, look, they already intersect. Okay, we'll keep graphing it though, but they already intersected the point 1, 1, which is what they should intersect at. So up 3, 1, 2, 3, over 1, like right there. And then these are also going to match all your points in the table. So let's do negative 1, negative 5. I lost what I was doing. Oh, so that would be down 3, 1, 2, 3, and over 1. Okay. And then you connect. That's not going to be straight at all. I did that badly. I'll go ahead and do it anyway, but that's not going to be straight. Oh, it's actually not as terrible as I thought. Okay. Okay. They intersect here. They both have the point 1, 1, which means our answer was correct. 1, 1 is the solution to this system of equations. 1, 1. That is where the two equations are equal to each other. All right. Okay. 4. So number 2, exactly what we did for number 1. 3 and 4, it says to solve them by graphing. Okay, so you're doing the opposite. So this time you're graphing first, and wherever they intersect is where they are equal. And then they want you to check your work. So we're just doing it backwards. So you're going to graph them. Wherever they intersect, that's where they're equal. Okay? And then substitute that point back into the equation. What do I mean by that? I mean what we just did. Let me just make one up real quick. I'm doing that. Let's do 5. Okay, so hold on. Okay, this problem is not on your homework. This is not on your homework, but it's very similar to 3 and 4. Okay, so it wants you to first graph. Oh, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so the first thing you're going to do is graph. So I like to start with my y-intercept. So I'm going to graph this one first. My y-intercept is 5. Oh, geez. 1, 2, 3, 4, 5. Well, I didn't leave a lot of room, so I'm just going to go down. Okay, so my slope is 5. Sorry, no, my slope is 2. So that means I'm going to go, it's 2 over 1. Okay, My slope is 2, so 2 over 1. So I'm going to go, it would be up 2 over 2, sorry, up 2 over 1, so like right there probably. And then down 2 over 1, down 2, 1, 2 over 1, down 2 over 1, down 2 over 1. Okay, I think that's far enough. So that's your first line. So just you can always make a table, but if they give you the y-intercept and the slope, I think it's quicker to graph it that way. Oh my goodness, I'm doing this really badly so far. I'll get better at this. I don't know why I'm so bad at it right now. Okay, we'll just do that. I'm gonna move my point so it actually goes on the line. So this is the point. -4, -3. Okay, this is our y-intercept, so that was 0, 5. Okay. And then graph your other one. So my y-intercept is 1, and then my slope is x, which means there's an invisible 1 here. So your slope is 1. So I go up 1 over 1, up 1 over 1. Okay? And then I would also go down 1 over 1, down 1 over 1, down 1. Oh, down 1 over 1. Why is that not working out? Hold on. Do. X plus 1, 2x plus 5. So you have, okay. For this guy, I have if x is 0, y is 1. Okay, if x is 1, y is, you know, x plus 1. So if x is 1, let me get rid of this. You have 1 plus 1, which is 2. If x is 2, y is 3. All right, let's go down in the negative direction. If x is -1, then y would be 0. Oh, no, I do have that. Okay, -1 is 0. And then -2, x is -2. Then y would be -1, -2. So I should be like right there, -2, -1. -3. If x is -3. If x is -3. -3 plus 1 is -2. -3, -2. There we go. Now we're going to match up. And then -4 and -3. I'll work on my graphing skills because that's not going to be straight either. Okay, but that is the point of intersection, -4, -3. So once you find the point of intersection, that's your answer. Now I want you to check it. So substitute -4, -3 into both equations and see if it works. Just like we did for numbers 1 and number 2. You're going to substitute this in. Does it work for this equation and this equation? And it should. So that's what you're doing on 3 and 4. Okay, let's go to number 6. So number 5, try by yourself. I'll do number 6 with you. Well, also try by yourself, but then come see me if you get stuck. So it says the Utah Jazz scored 102 points in a recent game. It's pretty good. The team scored some 3-point shots, some 2-point shots, and many free throws, which are worth 1 point each. Okay. Find 5 combinations of baskets that would add up to 102 points. Answers will vary. Okay. Personally, I like to make a table. You do not have to. You could make equations. You could make different diagrams, whatever floats your boat. I like tables. So we have, okay, so we have free throws. So we have 1 point. Actually, I'm just going to write free throw. Free throws are worth 1 point. Do we all know this? So I have free throws. Yeah. I have regular shots. All right, I'll put 2 points. So I have 2-point shots. That's anywhere shot within the 3-point line, right? And then I have my 3-point shots. And then, oh, my total. So my total, does it say it has to be 102? That have to add up to 102. So this has to be equal to 102. And that's the only thing we have to worry about. Oh, come this way. Come with me, and you'll be in a world of pure imagination. Sorry. Anyways, so this has to add up to 102. 102 points. Okay. So go ahead, pause me, because there are a ton of different combinations, so we will not all get the same ones. Okay. I don't know. Let's say, so I have to add up to 102. Let's say I make 10 free throws. So that's 10 points. Actually, I'm going to make that 12 because then the math comes out better. I'm going to do 12 free throws. Okay, so then that is 12 points. So 102 minus 12. 102. Oh, now I'm too far this way. I can't win. Come in a little bit. That works. 102 minus 12. Okay, and you get 90. So I have 90 points left. These are all worth 2 points. So what if I do 90 points left? You could just do, so I have 90 points left, so you could do, I make 45 of these, because you would multiply 45 times 2. 45 times 2. What's 45 times 2? 90. So that would be equal, that would be 90 points plus 12 is 102. So then you would make 0 3-point shots, and that would give you a total of 102 points. Okay. You could also make, let's make 20 free throws. Okay, so there I made 20 points. So 102 minus 20 is 82. So now I have 82 points left. Let's try, I don't know, 20 question mark? Sure, let's try 20. So I made 20 2-point shots. So remember, you're talking about points, so you can't just add these numbers up. 20 2-point shots. So you have to go 20 times 2. So that's 40 points. So I have 42 points left. All right, so 3 points. These are all worth 3 points. So how can I make, I need this number to be 42. Sorry, I need this number to be a total of 42 points. So 3 times what number is 42? Does that work? So I didn't realize I had paused it. I forgot. You can do 42 divided by 3 I need 42 more points. And these are worth 3 each. So I'm going to do 42 divided by 3, and that gives me 14. So that is also a total of 102 points. Okay, keep going, try a different combination. So what if I only get, it doesn't matter. We'll do 6. 6 free throws. This is kind of a lot of free throws to make in a game. We'll do 6. 6 free throws, so that's 6 points. Okay, so I need 102. So these are 6. So 102 minus 6, you get 96. Okay, so I still need 96 more points. So let's try 6 of those. What if I make... I want to make sure my last number is... Okay, so let's do 30. I make 32 point shots. Okay, so remember, how many points is this though? You're not just adding these numbers together. This means I make 32 point shots. So that's 30 times 2, which to get the number of points. So that's 60. All right, so that's another 60 points. So I need 36 more points to get to my 102. So once again, you can divide 36 by 3. Divide 36, I need 36 more points. And these are all worth 3, so 36 divided by 3, which is 12. And that gives me 102. Okay, if you get it, you can stop me at any time, but you need 5. If you want to start with the harder one first, maybe we should start here. What if I have, let's say I have 20 of these. So 23 point shots. How many points is that? 23 point shots. How many points is that? You go 20 times 3. 20 times 3. So you get 60. 102 minus 60. You get 42. Okay, I need 42 more points. Separate them out how you want. Let's make this. What if I also did 20? I also made 22 point shots. So how many points is that? Remember, you cannot just add these up. You're talking about the number of points. So if I have 22 point shots, how many points is that worth? If I'm a basketball player and I make 22 point shots, so that's me shooting, that's another 40 points. Okay, I just need 2 more points. This one's the easiest one, I think, because free throws are just worth 1 point. So I need 2 more points, which means I have to make 2 free throws. All right, so that's another one. That equals 102. What if we did... We'll make 10, no, 12. Did we do that? Oh, we did 12 already. Well, that's okay. We'll make 12 again. So 12 3-point shots. How many points is 12 3-point shots? 12 times 3 is 36. So you have 102 minus 36. Figure out what 102 minus 36 is. Did you get it? It should be 66. Okay, we need 66 more points to win the game. 66 more points. So let's make if you want, you could just say, okay, we're not going to make any free throws. We make 0 free throws this game. So then you just, if I have 66 more points and I'm only shooting 2-point shots, how many do I have to make? How many 2-point shots do you have to make to get to 66 points? 33. You divide it by 2. Okay, so that's another option. If you wanted to make some free throws, let's change it. Let's make it 30. I make 32-point shots. So then, how many free throws is that? Oh, sorry, how many points is that? 30 times 2 is 60. So I need 6 more points, so I need 6 free throws. All right, so those are some different combinations you could use. Sorry. Okay, number 7, don't stress about number 7. Just try and have fun with it. All right, use your spatial reasoning skills. There are lots of different answers for number 7. Don't stress about it. Just try it. It's just to get your mind working. Just try it. All right, 8 through 11. All you have to do is graph and then say, is the point 35 a solution? So they only give you one line. They're like, graph y equals 2x minus 1. So graph that, and then is the point 35 on the line? So if you graph it, I'm not going to graph it. Oh. Okay. So you're going to graph the line, and then any point on here is a solution to your equation. Any point on here is a solution to your equation. So you first have to check, is the point 35 on the line? If it's on the line, then it is a solution to your equation. All right, if it's not on the line, then it's not a solution. So if it's on the line, that's your key. And then it says to list other points that are solutions. Literally any point on the line. So like, this is just an example, but let's say this is the point 35. That's the point 35. So 35 is a solution. Yes. All right, let's make this 4, 6. So on this line, this is not a line on your homework. I just drew this line. So I could say 4, 6 is a solution. Let's say this is what, like 0, 4 probably. So 0, 4 is a solution. Any point that is on the line. Let's go there. That's like -2. So -2 and 0 is a solution. Any point that is on the line. So that's what you're doing for 8 through 11. Okay, we did this quarter 1, but it says that they represent different arithmetic sequences. That means arithmetic. They are adding or subtracting by the same number each time. They are adding or subtracting by the same number each time. Okay? So we have to fill in the numbers and then write the explicit equation. So for this one, sorry. Okay, so the first step is you want to figure out what is this difference here. From 17 to -7, what are we, first of all, are we adding or subtracting? If I'm starting at 17, whenever you have negatives, I like to use money. So let's say you start with $17, and then, now you owe the bank $7. So did you lose or gain money? You lost money, right? You went from 17 to -7, so we're subtracting. Okay? So, to find the difference, You can use a number line, you can count on your fingers, or you can go 17 minus negative 7. 17 minus negative 7. So you take the first number and you can subtract out the last number they give you. 17 minus negative 7. So that turns into 17 plus 7, which is 24. Okay? So 17 to negative 7, you lost $24. If we're talking about dollars, you lost a total of $24. Okay? That's your first step. Now, your next step is how many jumps. So I know that from 17 to negative 7, I've lost $24, but it's over 1, 2, 3. 3 jumps. 3 jumps. So you take 24, divide by 3. 24 total, and there are 3 jumps. So you divide by 3. Oh, sorry. You divide by 3. 24 divided by 3 is 8. And remember, you are subtracting negative 8. So you are subtracting negative 8 every time. And pick a different color. 17 minus 8. So 17 minus 8 is 9. Okay. 9 minus 8 is 1. 1 minus 8, here, minus 8, minus 8, minus 8. Subtracting 8 each time. 1 minus 8 is in fact negative 7. So there, you filled in your table. So now you need to write an equation for this, which I'll go over here. So y, it's linear. It's arithmetic, so it's linear. So I would prefer if you use this equation. Slope-intercept form. So your slope, what are you adding or subtracting by each time? Negative 8. So your slope is negative 8. And then your y-intercept is not given to you in the table. Your y-intercept is when x is 0. So, a couple different ways you can do it. One way is to do your slope backwards. So if x is 0, what is y? What fits the pattern? I'm subtracting 8 each time, so what would go here? Think about it. So you do your pattern backwards. So you go 17 plus 8, which is 24. No, it's not. 25. Okay, so that is your y-intercept. Okay, you could also write it in point slope form. Hold on. Some of you are probably going to want to write it like this. So your slope is negative 8, and then you do x minus 1 plus 17. That's also fine. I will also take that. Okay. Your slope is negative 8, and then you're using your first term. Okay, that's why it's x minus 1, because you're using your first term. And this is also a point in your table. 117, 117. You could technically also do x minus 2, plus 9. You could substitute any point from your table into here. So you could do 3 when x is 3, y is 1. Okay, this is what I prefer though. All right, so let's go back to what most of you will probably do. Okay, and you can, this is getting a little bit extra, but you could solve this. Do I want to do that? Maybe I don't want to do it. Yeah, I do. So if I simplify this equation, so I would distribute negative 8 times x, negative 8 times negative 1, eight plus 17 is 25. Okay, so these are equivalent. I can simplify this to get this. But this is the equation I prefer as slope-intercept form. Okie dokie. This is not a homework problem. I'm making this one up. So if you want to see another example of how to do this, let's do it. So once again, I tell you, and it tells you in the book, it is arithmetic. So I'm adding or subtracting. There. I'm adding or subtracting the same number each time. So I'm adding or subtracting. So let's look. I start at 21 and I go down to 6. Okay, we don't have any negatives, so you think of it as money, starting with $21 and I go down to $6. I'm going to think of it as cookies. I start out with 21 cookies and then all of a sudden I'm down to 6 cookies. So we are subtracting. Okay, we're going from a bigger number to a smaller number. Okay. So what are we subtracting? What is the difference between 21 and 6? How many cookies did I lose? How many cookies did I lose? I started at 21 and I'm down to 6. So once again, you can look at a number line, you can count on your fingers, or you can go 21 minus 6, 21 minus 6. What does that equal to? 15. Did you get 15? 15. So that is what I am subtracting within here. I lose 15. Now you count the number of jumps. So let's see, I have 1, 2, 3, 4, 5. 5 jumps. So you take 15 and you divide it by the number of jumps. So divide it by 5. So you get 3. I'm subtracting 3 every time. So now you can fill in your table. 21 minus 3, 18. 18 minus 3, 15. 15 minus 3, 12. 12 minus 3, 9. And 9 minus 3 is 6. Minus 3, minus 3, minus 3, minus 3, minus 3. Okay, you're subtracting 3 every time. So there, we filled in your table. So now for your equation, your slope is -3. What is your y-intercept? It's not given to us in the table. Figure it out, please. So your y-intercept is when x is equal to 0. So if x is 0, what is y? What would fit this pattern that we have? So my x's go 0, 1, 2, 3, 4, 5, 6. Okay, and I'm subtracting 3 each time. So then to figure this out, I would add 3 back on. So you get 24. Or you can write it in slope-intercept form. Y equals -3. And literally, you could choose any point on here. I'll just do the first one, x minus 1 plus 21. So I will also take that. This is in point slope because you have your slope and a point. This is in slope-intercept because you have your slope and the y-intercept. All right. Woo! That was a lot. They will not all be this long, but hopefully that was helpful. Feel free to rewind, fast forward, skip around, do your thing, do your thing. I will see you tomorrow.